guys, this is my third time to try this. I'm trying to get it under 15 minutes, so this is fast, okay? You need to put your phones up. You also need to make sure you're not using a graphing calculator. You have to use the little ones. Mine's on my desk or somewhere around there if you need it. You cannot share it during the test, okay? You have to wait till somebody's done. Here we go. First thing is domain. Domain, if a polynomial, you should know that. Those are the easy ones. If it's rational, the denominator cannot be equal to 0. So set it not equal to 0, factor the thing out, and both factors can't be 0. So y'all should know it can't be 5, can't be -3. You've got to throw those things into intervals. I should see 3 of them. Do your little unions in there, even though I just forgot mine. All right. If it's a radical, you know that is restricted because the insides has to be positive. So we're starting at -5 and we're going to infinity. So just solve that thing out, okay? Once we get into multiple parts or multiple options, I'm just going to pick the harder option and roll with that. Piecewise function, you've got to test and see where your number is. 2, is he less than 0 or greater than 0? Hopefully you guys said greater than 0. If that's the case, you're going to use the second option, and you're going to come in here and you're going to put your 2 inside. Please use PEMDAS. Remember, your exponents come before multiplying. If you get that out of order, yeah, our answers aren't going to match. Okay, greatest integer function. Let's do the negative one. That's the one that confuses everybody. If you take -6.7 and you add it to 5, that is going to bring us up to a -1.7. Then you have to do the little greatest integer magic, which means step down to the nearest integer. Okay? Keep that in mind. It's just like you're going down. So if you're at -1.7, you're ending up with a -2. The positive numbers work like normal. Okay, we really need to do one of these difference quotients. 4 is definitely the harder of the 2. Make sure you block it off. Oops, I forgot my subtraction sign. Okay, the second portion is always your original function. So everybody should be able to give me that. Then you're going to come in here, and when you're filling in the front, everywhere there's an x in your original function, you're going to use parentheses. Then you're going to come back in, and that's where the x plus h goes. All right? Go slow right here. You got to square it, twice the product, square the last. And then the rest is just distributing. So that should not, be too much of a trouble. Just make sure you're getting your signs right. All right, then you got to distribute this 3. Once you finally get them all distributed, it's not that big of a deal. I've got -5x, just a matter of copying at this point. Okay. Put your like terms together and we'll be done. Let's see here. Remember the check. These 2 from the back end, they should cancel. If they don't, that means you lost a sign somewhere, something's incorrect. The terms that we have left have an abundance of h's. Everybody's got one, which means you can reduce. And there you go. There's your answer. The first problem wasn't nearly that hard, so we went over the tough one now. All right, I cannot do all of these. I'm going to do the first 2. First one is very, very simple. You're going to have a vertex. Remember, we changed the sign. Keep the outside one. Here's your vertex. You're going to plot that point, and remember to use your slope. Up 3 over 1, up 3 over 1. Please show your dots, so even if your art is bad like mine, I at least know what you're thinking with your dots. Number 2 is the booger on the page. You have to complete the square, but it's nasty because there's a -3. All right, if you pull out the -3, that means that you're going to say -12 divided by -3 is +4. Leave a space. The -5's out here. He doesn't do all of this stuff. All right, now complete your square. Half of 4 is 2. 2 times 2 is 4. But what you really did was a -12. So to keep this thing balanced, you got to do +12. All right, your -3 is still there. Rewrite this thing. X plus 2. Put these together, 7. So your vertex is -2, 7. You'd plot that point and then use your slope. Down 3 over 1. The third one shouldn't give you very much grief at all. It's really like the first one. You just don't have anything in parentheses, okay? And your slope is 2. Once you did your vertex, you're going to go up 2 over 1. All right. The word problems, please don't let them give you fits. This is typed on the tests. I told you you weren't required to remember it. Please note that when it says how many seconds, that is time. Time is always where the x is. So if you will do the x portion of your vertex, then you can do this. Just remember, this is negative 16t squared plus 64t plus 0. So if you'll put all that stuff in there, it's negative 64, and then 2 times a negative 16. It's going to work out very nicely. Reduces to 2. You're done. Please don't flip out on the rectangle. You're trying to maximize area. If you maximize a rectangle, that means you turn the booger into a square. If it's a square, you should know all the sides are equal. You've got a perimeter of 360. Just divide by 4. Every side's got to be 4. And you're done. Yes, it can be a lot more difficult and involved, but we're doing it the quick way. Open intervals. Please don't bypass that word. Open just means please don't use brackets on this. We're going to use parentheses on everything. I'm not going to do them all, but I will give you some tips. I did leave off this word. There will be a blank for constant. Increasing is just positive slope. So you're going to tell me this is from negative infinity all the way up to, I do believe that's when x is 2. All right. Decreasing, I think it's going to start over here at 5 and go forever down. And then constant is the little section in between. This one, everything is increasing. So you're going to put the whole kit and caboodle up there, and none of these others exist, so please write D and E on these. I'm just trying to do this quickly. Increasing, there's not any, so that's a D and E. Decreasing, you have 2 sections, so please give me the 2 intervals that would exist, and for constant, you would have that one little middle part, so tell me what that is. Okay, graphing the function. This is so much based on do you know your parent graphs. X to the third, please know that he looks that way. I can't call it a vertex, but this little center of your squiggle, that's good. It's going to act like a vertex. That is located at 2, 4. So you go over to 2, you go up 4, he's anchored there. Check out his little slope. It's 1. So abide by the performance of your function. You can sketch him fairly quickly. You just did one of these on the other page. I'm not doing it again. We've already done those. Negative 8, 2, you know, slope of negative 1/4. He's just fat. This guy, remember, he looks like that. So it's not really a vertex, but our starting point is 3, 6. So go over 3 and go up 6. 1, 2, 3, 4, 5, 6. And you're going to start there. Slope is 2 over 1, up 2 over 1, and then do your little swish. You guys should be good. All right. You have 4 things to do, and 5 when you do the graph. Removable discontinuity. Remember, that is only when you can factor and reduce. So on number 1, there's no factoring involved. So D and E doesn't exist. So vertical asymptote is the factor in the bottom, set it equal to 0. Horizontal, it's your degrees. The degree of the top is 0 because there's no x's. The degree of the bottom is 1. It automatically then is y equals 0. Since you have a horizontal, you do not have a slant. Yes, you have to graph number 1. So you're going to come over to x equals 0 and then y equals 0. If you will do your y-intercept, you'll figure out where this goes. So put a 0 in for x, and when you put a 0 in for x, that is 4 over negative 1. So we have 0, negative 4. Okay, so come down here. He's hitting. That has claimed this section of the graph. You're going to get the diagonal of that. Okay, over here you do factor and reduce, so you will get a removable. Let's see here. There we go. The one that cancels, that's the removable. Just remember, set it equal to 0. The one that remains, that's your vertical. Horizontal, go right back up there. Use your degree rules. Degrees are the same, so you do your leading coefficients. 1 over 1, well, that'd just be 1. And you don't have one of these again. All right, hopefully we're getting close to being done. You do have all of the function operations. That's the top 4, guys. Be careful with subtraction. I'm not going to work it, but I am going to remind you to do 2 things. Pay attention to the order. This one says G minus F. Nobody said all of them had to do F and then G. So pay attention to order. And remember on subtraction, you've got first group minus second group. Distribute your negative. If you don't do it, part of your answer will be wrong. When you come down here, you will have composite functions. This is where you stick one inside the other. You will start with the one that's listed first. Wherever there's an X, you put parentheses. Then you come back in, and the one that's on the inside, he goes in the belly. Remember how that works? All right. Then you just work it out. Square the first, twice product, square the last. And then we're going to be distributing. This is 35x plus 7. Get your like terms together. 45x plus 8. Now, I will point this out to you. Pay attention to the correlation between these problems. This is f of g of x. This is f of g of negative 3. This is g of f of x. This is g of f of 5. Guys, if you do number 5 and 6 correctly, then 7 and 8 should not rock your world. I can take this answer that I have for number 6. I can use it then in number 8 and just go through here and put in my number. This will be a gigantic number, but it will be a number. And you can evaluate that thing and tell me what it's equal to. Just use your calculator. Okay, for 1 to 1, remember he has to pass the horizontal line test. You remember what x cubes look like? Okay, it has potential to pass the horizontal line test. So this is possible, yes. If it's an even exponent, that means both ends are up. It can bump and squiggle in the middle. But guys, it'll never pass the horizontal line test, so that's a no. To get inverses, remember your 4 steps. Put y in. Swap x and y. Solve for your new y. So it's 2 moves. Forgot my equal sign. Okay, now I've got to get rid of this cube. So I've got to do the cube root. So cube root x minus 2, and don't forget your little 3 out there. That just gives us y plus 6. Okay, when you move it over, don't be so sloppy that I cannot tell where your radical ends. I need to be able to see that the first number is under and another number is out. If you have this one, you may not even have this function. And then change it. It's no longer y, it's the inverse of f of x. If you do not use this notation, you will lose some points. All right, that should wrap it up. Good luck, guys.